Okay.
Okay, we had some problems with video. It's still not working. And so that Schoen will make his presentation without its slides, and maybe they come during the talk. And he's quite lucky. Okay. So Seth Schoen is staff technologist for the EFF, and maybe you heard about him. He figured out how the printers put the yellow dots on the paper so you can find all the printouts. And he will talk to us now about DRM and DVB, the digital video broadcasting, because the industry leaders want to put DRM systems inside of those two, so free broadcasting is maybe not a future for us. And it should start shortly.
How do I change the slide?
And Bild runter, and page down.
I'm going to start without the slides, and hopefully this will work while I'm speaking. I'll look at the slides here, and I'll apologize that you can't see them. Is it page up, page down? Okay. Ich möchte nochmal das sagen, dass ich kann nur wenig Deutsch sprechen, aber man kann schreiben auf Deutsch und ich kann das lesen. My slide has actually disappeared again. Okay. And I also can't see them at all, so the technical situation is tricky. So we at EFF have been part of the DVB project, a consortium that develops digital TV standards for Europe. Many of you may use standards on a regular basis that are work products of DVB. It's fairly expensive to be a part of DVB. It costs about 10,000 euro per year. And that's not counting travel for meetings and things of that nature. Just the membership fee to get the brass plaque to put up on the wall that says we're DVB members is 10,000 euro per year. So we got generous support from the MacArthur Foundation in the United States to allow us to participate. So we proposed a number of things in our several years of DVB participation. We wanted to defend the ability of people to use open source technology in connection with DVB. We wanted to maintain some existing kinds of compatibility and interoperability. So this didn't work out very well. I'm part of a group of Latin enthusiasts, and I remember I went to a dinner after one of the DVB meetings, and I was describing how the meeting went. And I said, well, it's sort of like, Socii concilium habeo, quid ni id non faciamus. And they say, est concilium pessimum, which is to say, hey guys, I have an idea. How about we don't do that? That's a terrible idea. So we didn't get a very warm reception. DVB has a concept that they have certain constituencies that are the official constituencies, and they include things like technology companies and broadcasting companies. And open source developers are not a recognized class of constituency. They do have a rule that nobody has a veto at DVB. So if they're doing something that you think is bad for you, you can't actually stop it, provided that a certain number of other people, a certain number of other organizations from the existing recognized constituencies want to work on it. DRM is very much something that a number of people from a number of existing recognized DVB constituencies do want to work on. At present, of the three leading DTV systems, ATSC in the United States, ISDBT in Japan, I'm sorry, I wrote down US again. That should say Europe at the bottom. Sorry? Not yet. Oh, well, the US sort of has ATSC. They're trying. You've got to give them credit for that, right? So at least with regard to free-to-air terrestrial broadcast, that's getting digital TV over the air from a tower, the DVB system has the least DRM of any of the leading systems because they haven't even completed a spec for doing any DRM with regard to free-to-air TV. And in the US, they've completed a spec, and there's a legal fight about whether anyone has to follow it. In the Japanese system, it's built into the system from the very beginning, and everything's encrypted end-to-end. So that's kind of the worst case. So in many regards, free-to-air as well as conditional access, which I'll talk about a little bit later on, DVB is actually in a really good situation right now. It's sort of an example of the fact that you can have a modern digital television system without DRM. Which is a proposition that's not really obvious to everyone. And so if you go around the world and you say to people, for example, in less developed countries who are talking about what digital television system to adopt, you can say, well, look, there are systems that don't have DRM. And DRM is not an inevitability, it's not a technical necessity. And the European DVB system doesn't have DRM. And that's pretty nice for Europeans, and it's pretty nice for other countries that might choose to adopt the system in its present form. Of course, if that were the whole story, I wouldn't be here right now. So back in the US, we've gotten a lot of things wrong. And unfortunately, some of those things are things that some people are quite proud of. And digital television is just one area where we've made some mistakes that people are really excited about. In this case, the entertainment industries are very excited about their successes at imposing DRM and technical restrictions in the US. And they say, you know, we've made progress in assuring content security, and now we need to make similar kinds of progress in other jurisdictions. This happens in a lot of areas of copyright. There's a whole office of the US government, the Office of the United States Trade Representative, and one of the major jobs of the trade representative is to travel all around the world and make threats to other countries to get them to adopt US-style copyright law. And that's been working really well from the point of view of the copyright industries. The US trade representative has gotten a lot of influence and a lot of success in getting other countries to pattern their laws on US copyright law, which is quite restrictive in many regards. And so we actually have a similar situation going on with regard to digital television, because the entertainment industries have said that they need DRM, it's essential, that there's no choice in the matter, and they're having some success in the US. And unfortunately, in all the years that we went to DVB meetings, we kept hearing US DRM initiatives held up as examples. People would say, well, we know, we need a broadcast flag-like thing, just like in the US. We need a thing like the US cable plug-and-play system, which I'm about to talk about. So here's our US mistake number one, called cable plug-and-play, also called cable card, also called a lot of other things. We have a notion that when you have a pay TV system as opposed to a free TV system, there's some kind of encryption, and the purpose of the encryption is to make people pay for the TV services. The mechanism for this is familiar to many people, either because they work in the industry or because they want to know about it for other reasons. What you're really paying for when you subscribe to a pay TV service is a stream of keys known as control words, which are able to decrypt the programming. Because you have a situation where you have a shared medium, like a coaxial cable that passes by everybody's house, or a satellite that's beaming some kind of modulated signal to everybody in the entire footprint underneath the satellite. And so you can't not receive the signal in a certain sense. Everybody who's there in the footprint on the shared medium is going to receive the signal. But the signal is encrypted, and there are particular keys that are constantly changing, called control words, that are necessary in order to understand the signal. And so when you get a pay TV subscription, the pay TV company is agreeing that they're going to use their complicated technical infrastructure to make sure that equipment that you have that's specifically registered to you, specifically individually numbered, is going to get these keys that it will then be able to use to understand how to decrypt the programming that you've paid for. So historically, and in many cases even today, the mechanisms of actually doing this, of actually decrypting the programming, of distributing the keys for decrypting the programming, and so on, were totally proprietary. If you wanted to subscribe to a particular service, you had to get a set-top box, you had to get proprietary equipment from that operator. So a lot of people are kind of mad about this. It's kind of a limitation on innovation and competition, because you have this bottleneck, because if the pay TV operator is very conservative or doesn't care, then you don't get new features. Also, the set-top boxes don't really come down in price and don't really take advantage of new innovation. So a lot of people have complained about this and said, actually, there really ought to be a competitive market for these devices. The US Congress in 1996 passed a law that said, with regard to cable in the United States, there ought to be a competitive market for devices that can receive cable. They should be standardized. They delegated to the industry the power to create the standard in question. So this ended up causing some problems for us. One problem was that the industry wasn't in a big hurry to get the job done, and it took them years and years, and the system has still not been properly implemented in the US. And this is 10 years after the legal mandate to implement it. So one problem is the delay. But of course, that's not the only problem. The other problem is that the system is secret and proprietary, and to build a device, you have to get a license, and the license strictly regulates the functionality of the entire device. In particular, you have to impose, under the terms of the license, DRM after reception. That is, after you've verified that people have paid for something and you've decrypted it, then you've got to go and look up the DRM policy, and you've got to enforce the DRM policy against the user in the user's own living room. So technically, that wasn't necessary. You could have just said, did the user pay for this? Okay, the user paid for this. Okay, here's the MPEG stream. Unfortunately, the industry felt that they didn't have any reason to draw this distinction between conditional access, that is, did the user pay for it, and DRM, that is, what can the user do with it? What kind of devices can the user do it on? What abilities does the user have to make use of it? So conceptually, these are different, but there was no profit that the industry saw in maintaining that distinction. So we complained about this to our communications regulator. We said, wait a minute, Congress said that there should be this compatibility thing. Congress didn't say that there should be these restrictions on consumers as a part of that package. The FCC ruled against us. They said that this system was totally fine and was a legitimate example of what Congress might have had in mind. So that was kind of depressing for us. I also want to mention that in the US, this regime only applied to cable and not to satellite. In the US, we have only 2 mainstream commercial digital satellite companies called DirecTV and EchoStar. These companies are not subject to any kind of compatibility regime for their devices. So if you want to get their service, you have to get their set-top box. So this creates an interesting baseline question, because we have this cable plug-and-play regime. We have these devices that are licensed, that do DRM, that restrict the users, and a lot of people in the industry say, this is a great step forward for consumers. Because the normal situation, if we didn't have this regulation, the normal situation is that all of the pay TV operators would hand you a set-top box, and whatever that set-top box did or didn't do would be the end of the story. You would have no recourse, you would have no other options. You would take their set-top box and you would like it. And so they say this cable system that has these restrictions is really good for consumers because at least consumers are guaranteed that the system can't be any more restrictive than that. And this argument is very persuasive to people in the industry because they say, you know, normally operators would have every right to impose any proprietary restriction they want. So any step away from that is more freedom than consumers really could have expected at the outset. Whereas you could say, well, compared to an open system, it's still extremely restrictive. They can still prohibit you absolutely from recording certain programming, for example. And in a more open system, they wouldn't have that power. And the industry would probably respond, why did you think you were entitled to an open system? So moving on to mistake number 2, we have this DTV standard called ATSC. Since the satellite systems in the US are proprietary, as I mentioned, they don't actually use ATSC. So this is a distinction between the US situation and the European situation. Because here in Europe, DVB standards are used for satellite TV, for cable TV, and for free over-the-air broadcast. DVB-S, DVB-C, and DVB-T. We don't really have the equivalent situation in the US. We do have a DTV standard for broadcast, and it doesn't include encryption, perhaps because it was written about a decade ago. So the movie industry got really mad, but they got really mad on a kind of a late schedule, because they showed up after the system was standardized and after the system was adopted and implemented, and there were actually stations on the air broadcasting using it. And they said, wait a minute, why is there no DRM? That's unacceptable. So their response to this was not to actually try to change the standard, but rather to say, well, these devices, these manufacturers are being totally irresponsible because they're making devices that can just copy and can just record anything. And that's not really looking out and doing their part for the long-term health of the content ecosystem and the value chain. So we need to set these people right, and we need a little regulation to help them along, to help them see their way to doing something that's in the long-term interest of the content ecosystem. So their solution to this was a regulation that we call the broadcast flag, and the idea there is that you have an unencrypted signal, and you can understand it, but by law you have to pretend that it's encrypted, and you have to apply restrictions on the other end, as though it were restricted coming in. So I have an analogy to this. Imagine that a bunch of people were having their emails leaked to journalists, right? Like a corporate CEO sends out a sensitive memo in email, and then someone forwards it to a journalist, and then it shows up in the press, it shows up in the newspaper. So the CEO is really mad and says, look, these email software authors are being really irresponsible because they're making email software that has a forward button, and the forward button is always there, and the forward button is always enabled, even for sensitive internal corporate documents. Now, obviously, if email is really going to be a valuable and useful technology, we need to have the ability to have an appropriate policy that indicates whether email can be forwarded or not. So we're going to have an X no forward header. Okay, so email will work just like normal, except if there's an X no forward header and it's set to 1, then an email client should not allow the forward button to be used. Well, Microsoft has a slightly more complicated approach to this, which involves actual encryption in some cases. Whereas in this analogy, it's important to note that there's no encryption going on, because you don't actually want to re-engineer the protocol. You just want to say, there's a behavior, and we demand that implementations exhibit this behavior. And so in the analogy, they're saying any email software that's willing to forward email that contains a no forward header is naughty and shouldn't exist, and we need a regulation saying that all email software authors have an obligation to look for and obey the X no forward header so that emails won't be leaked to journalists. So they actually persuaded the communications regulator to enforce the equivalent thing with regard to the open, unencrypted ATSC digital TV standard. This irritated us very much. So we took them to court, and we challenged them in court. Unfortunately, our lawyers, being very clever and skillful lawyers, they didn't actually say in court that this was a bad idea or a stupid idea or that it was the wrong decision. They adopted the much more successful legal strategy of saying that the communications regulator didn't have the authority to pass the rule. And that worked. And we got the rule thrown out. But the trouble is that the court didn't actually say that it was a bad idea, right? The court said, oh, well, you didn't have the proper authority to do that. You need to get the authority from Congress. So, of course, Congress is still very interested in giving them that authority, and we still have this political issue, because the regulation could be reinstated at any moment if Congress were persuaded to give the authority back to them. So we won a very nice victory, but it's potentially a very temporary victory. So as I mentioned earlier, DVB has been a really nice example, because here we have a complete suite of DTV standards that basically don't have any built-in DRM facilities historically. And that's even true for pay TV, which is actually really surprising to people in the US. That is to say, if you're using a pay TV service in Europe that supports the common interface, and not all services do, but some services do, then you have a documented standard way to get your pay TV that you still have to pay for, at least in principle, and you pay for this and it comes into your house and there's a particular point where it actually gets decrypted and then you've received it, and then you've got an MPEG stream. And this is true for both cable pay TV and for satellite pay TV, if you have systems that use common interface. So you get a lot of cool stuff as a result of this. For example, open source PVRs on computers. You have Myth TV, you have VDR, you have the ability to have a card in your computer that's lawfully decrypting pay TV service that you paid for and giving you the ability to do all kinds of stuff with the MPEGs afterward. In fact, a lot more sophisticated than the things that the commercial PVRs allow you to do. Also, having this open standard gives you an example. When someone says, we need DRM in everything, DRM is the normal way to do things, you can say, well, we've got the DVB protocol suite, and people are actually using it, and they're actually putting TV out there, and it doesn't do DRM, and the sky isn't falling. So what's the problem? Unfortunately, DVB is now working very hard to reverse this situation, to make it exactly the opposite, to create some of the most restrictive DRM for digital TV in the entire world. And they're doing three things that we worked on and tried to stop and did not stop in the standards committees. And I'm going to talk briefly about each of these three things. And then I'm going to ask if anyone has any ideas for how to stop them. Because to my regret, and predictably, we did not manage to stop them in the standards committees, and they're still going forward in the standards committees. And there are still a lot of people in European TV industry and entertainment industry, and American entertainment industry, who are very interested in seeing all of these things implemented in practice in Europe. So the three things are a DRM system called CPCM. I'm sorry for the acronyms. There are a lot of acronyms. I don't know what to do about that. I'm actually sparing you a lot of acronyms, but I'm still throwing a lot of acronyms at you. The second thing is a revision of the common scrambling algorithm that's associated with the revision of the common interface. And I mentioned the common interface earlier. And a number of you, if you're subscribers to pay TV services, may actually be using the common interface now. But the common interface is being revised. There's a new version being created with a lot of integrated restrictions that simply don't exist in the current version. And finally, there's a specification being developed for a broadcast flag, almost exactly parallel to the US broadcast flag, that would apply through regulatory measures to free over-the-air DVB-T broadcast. So CPCM is a really modern DRM system. It hasn't been implemented, it's only a specification. This specification is actually publicly available, although it's still not done. It's called the DVB CPCM Blue Book. It's very dry reading. One of the really significant things that it does is specify a really large number of extremely specific restrictions that can be imposed on users. And I mean really specific. So one of the real obsessions that the Motion Picture Association of America has had recently is geographic control and proximity control, and trying to figure out where devices are in physical space. I've thought of this as reimposing geography on the internet. Because you go to these meetings and people talk for hours and hours about, well, this device has network connectivity to that device, but that doesn't mean they're in the same room. We've got to have a way to call a function that will tell us if these devices are in the same room or not, so that we can have a policy that treats devices differently when they're in the same room and when they're not in the same room. And people are talking for hours and hours about specific ideas about how to put geography back into the internet. Because, you know, we have devices, people get excited because they say, we don't have to rely on geography. We can do things remotely. And the view of the CPCM system is that being able to do things remotely and being able to do things over a network and being able to do things in another building is a privilege, not a right. And there ought to be a way to express policy about it, to decide whether you're allowed to do it, to say specifically whether you're allowed to do it, and to what extent and in what circumstances. So we have this huge list of possible policies that can be imposed, and it's very long. And it's essentially a complete laundry list of things that MPAA would like to be able to assert as policy in a modern DRM system. Also, the purpose of the CPCM system, as many participants at DVB have said, is to be used with the common interface, to be mandatory for use with the common interface in Common Interface version 2. So when the common interface is updated, when it's replaced, all devices that want to get content, that want to get MPEG streams out of the common interface, are going to be expected to implement this or an equivalent. Let me just give you a couple of quick examples. This is a tiny subset of the huge list of policies that are in CPCM. You have geographic area, which is presumably a particular polygon on the surface of the Earth, presumably defined with trusted GPS. So you have tamper-resistant GPS inside a particular device. There are other ways of doing this too. If you want to invent another one, MPAA will be proud of you, because they want to give implementers choice and flexibility in how they enforce restrictions. So you can imagine drawing a polygon and saying, you know, from this GPS point to that GPS point to that GPS point, and if you're inside that space, then you're in a geographic area and you're authorized to view this, or potentially authorized to copy this. Then we have local environment. This is if you can prove that you're physically near another device, you may, at the option of the copyright holder, be authorized to copy between those devices. And they can define what verifiably physically near or in proximity means. And again, they have a whole list of ways of testing this, and if you can come up with another one, again, the MPAA will be grateful because you'll be giving choice and flexibility to the implementers. But we have things like cryptographic pings. So you ping someone and they sign the response cryptographically, and then you measure the latency in milliseconds, and if it's more than so many milliseconds, then you haven't proven that you're on the same physical local segment. And they have a whole lot of things that go on from there. One of the really silly ones that they're thinking of using is IP time to live. Yeah. I think someone will talk them out of that before they implement it, unfortunately. And then there's a concept of authorized domain that's very offensive to some people because it arose out of the idea of letting devices determine in their binary kind of way whether they're part of a particular household and whether they're part of the same household or not. This means that you have to make a mathematical model of what constitutes a household, and that's kind of offensive to a lot of people. Obviously, you could look at it another way and say this is just an arbitrary set of devices that are allowed to share content. If you say that they're mathematically modeling your household and deciding whether your household is mathematically acceptable or not, then that kind of annoys people. If you say, this is the set of devices that constitute the AD, then that's somehow not disturbing in the same way. But it arose from a household modeling idea, and there's a hypothetical algorithm called the Authorized Domain Management algorithm that determines if devices have historically been close enough to one another to be legitimately referred to as constituting a household. We don't know what the algorithm is. They say that's a compliance issue. Some other entity has to actually write the algorithm. We're just going to create the vocabulary that they would use, the concepts that they would use. And so obviously there's a whole Venn diagram. It's very elegant, right? You can have GA plus LE or GA plus AD or any combination of these plus any number of other things. expiration dates, numerical copy counts, really fine-grained control. And again, the purpose of this is, oh, I'm sorry. I did page down here and not there. Sorry, I should have had this slide up while I was talking about those three things. So we have the geographic area, the local environment, and the authorized domain. And many, many other things. All right, so the purpose of this, again, is for the common interface. The common interface is an open interface, an unencrypted interface that's used. I think something's gone wrong here, so I think I could use some help here once again. That may be why it didn't page down. Thank you. So the common interface is an open interface, as I said, an unencrypted interface that's used in conjunction with pay TV in the DVB system, used in conjunction with conditional access programming, so that you can have a proprietary means of determining whether you paid for something, and then an open set of devices that can actually receive the programming after you've paid for it. This is a pretty cool idea. There's actually European legislation that requires some manufacturers to support the common interface on the grounds that it's very pro-competitive, and I'll talk a little bit about that later on. So again, it's not encrypted right now. If you pay for the programming, it gets decrypted, and then you can do what you want with it. People at DVB think this is horrible. They can't believe that anyone actually would have designed it that way, even though it was they who designed it. But they designed it back in the pre-DRM era, when we didn't know that these rights have to be enforced by technology. And so the obvious conclusion is that when they do the new version, they're going to have some intellectual property, trade secrecy, patents, and other things in the new version of their common scrambling algorithm. And they're going to license the devices that are able to interoperate with the new common interface. By default, they're going to forbid all recording. And that's the default state that they're going to start from. It's a bit different from what we have now, if any of you are using common interface cards in your PCs. And then later on, they're going to negotiate and figure out a way to enable some recording using a DRM system or policy expression system similar to or identical with CPCM. Okay, so why does the industry think it's okay to do this? First of all, they say, well, it's their content, so they're entitled to do it. Okay, even if they're not entitled to do it, they can. Because as a practical matter, if you have a particular kind of conditional access system that doesn't do these restrictions, that doesn't have the CPCM rules and policies and expiring recordings and whatever, then they can refuse to license their Hollywood movies or their sporting events or whatever for distribution via that system. For example, they can boycott CA systems that are not capable of enforcing these rules. And in fact, in the European pay TV market, there are some CA systems that are intentionally not compatible with the existing common interface. So in the existing market, the pay TV operators have the ability to decide whether they want to support common interface or not. And unfortunately, that fact gives the movie studios a lot of leverage because they can say, if the new common interface isn't restrictive enough, we're not going to license things to those pay TV operators who choose to be compatible with the thing that we think is too permissive. And that's a big problem, and I don't think that I can really overstate how big a strategic problem that is. So again, it's a conscious decision to say that the current common interface is too open, needs to be made less open. You have devices like PCI cards that do common interface in a PC, and those devices couldn't be made in the form in which we know and love them. Basically, you have some amount of tamper resistance in conditional access, and just as with the US cable plug-and-play system, there's an intentional decision to spread the tamper resistance down into the device and down into your home. Right, so you have a smart card. The smart card is tamper resistant. It contains policies about making sure that people pay for things, being able to be turned off if you don't pay. So we can argue about that, but there's not much to be done about that within the pay TV model. There's got to be something tamper resistant if you're going to have a broadcast signal that only some people can receive. Okay, so then you have some crypto hardware that actually does the decryption, and that's tamper resistant too, because it's actually got the keys, and if it weren't tamper resistant, you could get the keys out and tell them to other people. Okay, so then you have a host device that this is contained in. And the host device is something like a computer or a set-top box. Now, that doesn't have to be tamper resistant. It's not tamper resistant now, but this CI version 2 idea is, well, why not, right? Where's the harm? And then that device will be required to do DRM on its outputs and only talk to other devices that are licensed. And so you get this real infection of tamper resistance, of licensing, spreading into your home. And finally, DVB is working on a broadcast flag for Europe, and it's inspired by the US broadcast flag. And this is applicable to unencrypted, free-to-air DVB-T programming. So the US broadcast flag does this. There's a weird situation here in Europe because the public service broadcasters have a notion that it would be illegal for them to allow their programming to be encrypted. So they're asking for something called do not scramble, which is a flag that says that you have to enforce DRM policies but without encryption because of their interpretation of the legal situation. This has led to really bizarre arguments at DVB about how you enforce DRM without encrypting stuff. Of course, the people other than public service broadcasters are saying, well, that's okay because we're sure not going to use that flag. We may use the flag that enables the restrictions, but we're sure not going to use do not scramble. So whenever we complain about the fact that this is going to break lots of things that we enjoy now, DVB says, well, look, we're just defining some bits. We're not saying that anyone actually has to do anything with them. If there were someone else who wanted to enforce compliance here, well, they could try to do that, but that's not what we're doing. So you can't blame us. We're just, writing a spec for something. Someone might want to use it for something, maybe. This is, in fact, what the US ATSC Standards Committee said about the US broadcast flag. We're just defining a couple of bits of metadata. You can use them or not use them or whatever, and if any communications regulator happened to see them lying around and wanted to make a law saying that it was illegal to ignore them, well, that would be interesting. So there are some potential regulatory issues that are likely to develop. As I mentioned earlier, the common interface version 1 has a special status. Device manufacturers are required to support it. Pay TV service operators are not required to support it. This is actually the inverse of the US situation. In the US situation, cable companies are required to support cable plug-and-play, but hardware companies are not required to support cable plug-and-play. In Europe, hardware companies are required to support the common interface, but pay TV operators are not. This unfortunately produces a lot less leverage for consumers and a lot more leverage for movie companies because there's all this hardware that has to support common interface, but TV companies could just not do it if it doesn't do DRM restrictions. There is a question about whether regulators will recognize this restrictive proprietary CI version 2 as the legitimate successor of CI version 1 and what consequences that would have. And then with regard to the broadcast flag, will devices be required by law to obey the broadcast flag? And already the movie studios are saying that this is something that ought to happen. And this is something where regulation would be necessary and where they hope to or expect to advocate and ask for that regulation. If you talk about consumer protection issues, a lot of people say, well, we can just have some regulation to deal with that too. For example, if you think that this particular thing is too restrictive, we can say that in a particular member state, it will be illegal to apply that restriction to a particular kind of programming. This is all very abstract because no one is willing to go on record actually opposing any particular use of any restriction. But hypothetically, if you thought that some restriction were bad for consumers, you could have a hypothetical regulation saying that it couldn't be used in some circumstances. But in the status quo, we don't have any DRM at all. So if you put some DRM in and make all these devices get licenses and make all these devices become tamper resistant, and then say some of that DRM sometimes can't be used by certain categories of broadcasters in certain countries, I don't think that's a very effective remedy compared to not doing DRM. So help. We're in a tough situation because over at the DVB project, ideas like people might want to use common interface in PCs and record stuff on their computers seems incredibly weird and marginal. Like, what? People watch TV on computers? I've never heard of that. And we say, yeah, they do. You know, I read it on the internet, and I met this guy who was working on a project. And they say, well, we sold 20 million units last year, and you just know this guy on the internet who is working on a project. So I think our 20 million units are more reality than your guy who's working on an open source project. So that's kind of a problem in terms of convincing people that this is even something that's real and worth worrying about. Also, pretty much everyone in industry doesn't object to DRM. Also, movie studios have a lot of leverage because they can say we're not going to license movies. Same thing for sports. People can say, if you don't get these restrictions in place, we're not going to let you have access to our cool content. And regulators don't have a lot of history of really aggressively resisting DRM implementation as opposed to facilitating it, as many of you may know if you've been lobbying in the EU about DRM issues. There's a lot of pressure and a lot of difficulty. So I really would like to know what can be done about this, because we've been off arguing with people at DVB about it and saying that it's bad, and they've been saying, no, it's good. And that's where we are. These things are regulations and contractual developments, private developments that could come about, that could put a lot of DRM into DVB standards that currently don't have any. And I don't really know what we can do about it, and I hope that some of you do, because I'd very much like for it not to happen, and I wish I had a specific program and project about it. So I'll take questions or suggestions or comments or anything of that nature. And as we mentioned last night, EFF is going to be hiring a person in Brussels who's going to be doing lobbying at the European institutions level. So if any of you do have ideas or interest in this area, we are going to have someone here in Europe whom you may be able to work with and cooperate with on that. And I'm sorry again for the technical difficulties, and thank you very much for your attention. And I think we have only about 5 minutes if I understood the signs properly. There's a microphone, is it there?
Thanks. I have a question.
I think that...
Shall I go ahead? Go ahead. Okay, I'll go ahead. I think the main problem in terms of what can we do is the language and the way in which it's all being described. I mean, I think the problem really is one of communication. I think that even, you know, translating what you're trying to tell us with great passion and great kind of, you know, you're obviously really concerned about it. It's not really coming across perhaps as clearly as it needs to for the general public to become aware of the potential problems. So we held a meeting recently about DRM, and the solution suggested was to come up with some kind of clearer communication, like labeling. If you put on devices, you know, do you know that you can't do this? And I think it might be worth thinking about a communication strategy and going down that route, because it's coming across as obscure when in fact it needs to be incredibly simple so that the general public start to object to the problems.
I think that's a great point. From my point of view, I took out a lot of acronyms. But there sure still are a lot of acronyms here. There sure still are a lot of fine details. And it does seem that if we can make things more concrete for people in some way. One of the difficulties, of course, is that DVB only does part of the job, and then they defer to other entities and other licensing entities the power to actually implement things. So, for example, when we talk about households and defining a household, which is something from a communication point of view that's bothered people a lot, that someone's going to define what your household is. Well, the actual details of that not only have not been defined by DVB, but are not going to be defined by DVB, but they're going to be defined by some hypothetical industry body that will be created later on to handle that task. So we can't point to a specific thing and say, this is what they mean by household, and that's not your household. So there are obstacles in that area, but I think that that's a great point about communication.
Okay. What can end users do to stop the spread of DRM in TV?
I don't know what end users can do. I'd love to know what end users can do.
What about doing things like building myth TV boxes?
Well, so with regard to the broadcast flag in the US, we encouraged people to get hardware that was going to be made illegal before it was made illegal, and then do stuff with it. And that was pretty fun. It didn't happen on a very wide scale. CCC might be the right audience for that. That is, if there is a broadcast flag proposal that gets introduced, you have a window of time in which you can buy things that would be banned, and then those things will keep working because they're not making a fundamental change to the DVB-T standard that would make it incompatible. Unfortunately, that solution doesn't address the CI version 2 problem. Just as our Myth TV project in the US didn't address cable plug-and-play, it only addressed broadcast flag. Because with cable plug-and-play, there's encryption and you need a license to interoperate. Similarly, with CI version 2, there's encryption and you need a license to interoperate. There's nothing you can go to the store and buy that will keep working with regard to CI version 2, whereas with regard to broadcast flag, there is and there might be. And we can try to do the same thing and say, go to the store and get this thing before they ban it. But that only, again, solves part of the problem, not the whole problem. Sounds like we're out of time, so thank you very much. I hope to see some of you, if any of you are working directly with DVB technology, I'd like to talk to people about how it will affect your particular projects. And thanks very much.